Hello, my dear students. Today we are going to study about the law of conservation of momentum practical application. We have already derived two derivation. First from the Newton's second law of motion, and second we have derived derivation from the Newton's third law of motion. So now we are going to see practical applications of the law of conservation of momentum. So it's a simple example is recoil of a gun. It means जब हम गन से, पिस्टल से या कोई भी राइफल से जब हम बुलेट को फायर करते हैं तो बुलेट तो आगे की ओर जाती है, बट गन जो होती है वो बैकवर्ड फोर्स लगाती है। तो रीजन उसका क्या है, तो उसी के बारे में आज हम डिटेल में पढ़ेंगे। इसका बेस्ट एग्जांपल वैसे एक नई मूवी आई है जो शाहरुख खान की, जिसका नाम है जवान। उसमें दिखाया गया है, उसमें काफी कुछ ऐसी चीजें हैं जो बच्चों को देखनी चाहिए विद पेरेंट। वैसे तो एज ए फैकल्टी, एज ए मेंटर मुझे नहीं कहना चाहिए कि बच्चों आप लोगों को मूवी देखनी चाहिए, लेकिन कुछ मूवी है जो वाकई में आपको अपने पेरेंट के साथ देखनी चाहिए, जो कि अच्छी मूवी है। लाइक शाहरुख खान की जवान मूवी, फिर एक अक्षय कुमार की आई है OMG 2, जो सेकंड पार्ट है OMG की, ओ माई गॉड। और वो रीज़न ये है कि एजुकेशन का पर्पस क्या है, आप लोग बच्चों को एक अच्छा फिजिकली और मेंटली स्ट्रांग बनाना। वो सोर्स कोई भी हो सकता है, एज ए टीचर भी हो सकता है, एज ए कम्युनिकेशन आपकी मोबाइल भी हो सकती है, एक इंफॉर्मेशन की बहुत बड़ी कह सकते हैं मीडिया, जो आपकी सिनेमा है, थिएटर है, वो भी हो सकती है। तो अगर अच्छी मूवी है तो इन्फॉर्मेशन लेने में कुछ गलत नहीं है। कुछ सीखने के लिए आपको मीडिया की ज़रूरत है, तो वो मीडिया कुछ भी हो सकती है। एज ए फैकल्टी, एज ए मेंटर, मैं चाहूँगा कि आप बच्चे भी जवान मूवी देखें। उसमें काफ़ी कुछ जो इंडिया में हो रहा है, जो कि रियल में हुआ है, उसके बारे में बताया गया है। एजुकेशन का पर्पस क्या है आपका, वो खुद ब खुद समझ में आएगा। एक तरह से कह सकते हैं मोटिवेशन मिलेगी आपको पढ़ाई करने की। और इसमें एक और एग्जाम्पल भी आपको मिल जाएगी कंजर्वेशन ऑफ मोमेंटम की। इसमें बंदूक के बारे में दिखाया गया है कि आर्मी जो हमारी जवान लोग हैं वो कितने करेजियस होते हैं, कितने ही बहादुर होते हैं, कितने ब्रेव होते हैं। लेकिन ये ब्रेवनेस, ये करेजनेस किस काम का, अगर उनके हाथ में जो पिस्टल दी गई है या जो आर्म्स दिए गए हैं वो अगर काम ना करे बैटल फील्ड में, तो यही सब चीज़ों को उसमें दिखाया गया है कि कह सकते हैं काफ़ी अच्छे मुद्दे उठाए गए हैं जवान मूवी में, जो कि आप बच्चों को विथ पेरेंट्स के साथ देखना चाहिए। इसीलिए मैंने उसका थोड़ा सा एग्जाम्पल लिया है। लेट्स लुक एट जवान मूवी टेलर। ये जवान मूवी की टेलर है। ये हमारे देश की जो हमारे देश में होने वाली घटनाओं के बारे में इसमें दिखाया गया है। हमारे देश में होने वाली हर घटनाएं एज ए स्टूडेंट, एज ए पेरेंट्स आपसे जुड़ी हुई है, आपसे अलग नहीं है। नाउ वी आर गोइंग टू स्टडी अबाउट द practical application of the law of conservation of momentum. So we have already derived two derivation, one from the Newton's second law of motion and another from the Newton's third law of motion. So the law of conservation of momentum, now we are considering from the Newton's third law of motion. That is a, what we know about that? We know that before collision of the total momentum equal to after collision of the total momentum. Now here we are going to fire from the gun, so we are considering before firing of the total momentum equal to after firing of the total momentum of the gun. So let's example recoil of a gun. Recoil means जब हम किसी गन से बुलेट को फायर करते हैं तो गन बैकवर्ड डायरेक्शन में एक फोर्स लगाती है, एक किक देती है, जिसे ही हम रिकॉइल ऑफ ए गन कहते हैं. ओके, सो नाउ वी आर गोइंग टू प्रूव दैट हाउ अ गन रिकॉइल. सो कंसीडर, लेट्स mass of the gun equal to capital M. Okay, mass of the bullet equal to a small m. Okay, before firing, what happened? Before firing, both gun and bullet will be in rest position. Both before firing, both gun and bullet are in rest position. Okay, we have to consider after firing. What happened? After firing, bullet will be moved with velocity. Okay, that is, we are going to represent a small v velocity, and we know that velocity is a vector quantity, so we are representing here v velocity like this. Okay, what happened about gun? Gun will be move with velocity, that is, we are going to represent capital V. Okay, so what we know about the law of conservation from Newton's third law of motion? Newton's third law of motion says that before firing of total momentum of the gun equal to after firing of the gun of the total momentum of the gun. The total momentum of the gun. And most important thing, no any external forces acting on the system. Okay, so what happened before firing of the total momentum? How much? That is a 0. And after firing of the total momentum of the gun, that is a small mv, that is a bullet of the momentum, plus capital mv, that is a total momentum of the gun. So we simplify, we have to find the velocity of the gun. So we are going to just solve simple equation like capital M V equal to minus a small mv. Okay, you have already studied about the how to solve equation in mathematics, so we are going to just simply solve this equation. Okay, we have to find velocity, capital V velocity. So simply capital V velocity is equal to minus mv by capital M. Okay, so we got the conclusion that capital V velocity is the velocity of the gun and a small v is the velocity of the bullet. Here we got the negative sign. Here we get the negative sign. It means both gun and bullet velocity will be in opposite direction. Okay. And mass of the gun is more greater than mass of the bullet. So velocity, what will happen? Velocity, mass velocity of the gun will be lesser, more lesser than the velocity of the bullet. Okay, because here is a mass of the gun more, so velocity will be less of the gun. Simple. So राइफल को जब हम चलाते हैं, how to fire from the rifle? Simply like this rifle, we have to put on the shoulder like this. Okay. When we fire, then what will happen? Bullet will be go forward direction and gun will be hit backward direction. So you have to very strong shoulder to fire the rifle. Okay. Another example of the law of conservation of momentum is, you have already seen the rocket propulsion. Have you seen how rocket start going up? How rocket fly? Simply so many powerful engine, so many powerful fuel, one downward direction generate so many heat. So rocket engine go upward and fuel. Another example of law of conservation of momentum, you can see in the rocket propulsion. When rocket start, so many fuel burn and downward direction, so many forces applied. That's why rocket go upward in the sky. So my dear students, now we are going to study about equilibrium of concurrent forces. First we have to understand what is a concurrent forces. Concurrent forces, it means when forces, so many forces, not a only single forces, so many forces acting on the same point on the body, that is a concurrent forces. Okay. What is the equilibrium of concurrent forces? When concurrent forces and unbalanced forces is become zero. Okay. Then in a straight line motion, other in a uniform motion, or in rest in position, all forces are in equal. So that is called equilibrium of concurrent forces. Let's see how. Now let's see, forces acting at the same point on a body are called concurrent forces. When a number of forces act on the body at the same point and the net unbalanced force is zero, the body will continue in its state of rest or of uniform motion along a straight line and is said to be in equilibrium. Simple. So let's consider F1, F2, F3 are concurrent forces. Okay. Acting at the same point, that is O. Okay. See how force F1, that is point O, then second F2 and third F3. F1 will be first forces, F2 will be second and F3 will be third forces acting on the point O. Okay. So these all are vector forces. Okay. So how we will conclude? How we will find final forces? So we have to apply parallelogram theorem. Okay. So what is parallelogram theorem says? Simply, let's consider in triangles law, that is a f1, and we know that the we can shift parallel, we can't move we can't move vector quantity, okay, but we can shift parallelly. So generally we are just shifting parallel, so we are just shifting vector quantity, okay. So now how we will get the final, means final vector quantity? So when we have to find final vector quantity, how we get the resultant quantity, resultant force? So we know that resultant force will be like this, okay, that is a f3 we have. So what we get? F3 is equal to minus f1 plus f2, okay. So when we solve the equation, we get the f1 plus f2 plus f3 equal to 0. All are vector quantity, okay. Simply we have to represent vector quantity, okay. So that is a equilibrium of concurrent forces, says that. Equilibrium means all forces are equal, okay.